Hi students, problem number 11. Ultraviolet light of wavelength 1800 angstrom unit is incident on a lithium surface whose threshold wavelength is 4965 angstrom unit. Determine the maximum energy of the electron emitted. That means kinetic energy maximum we have to determine. So there are two wavelengths given here. One wavelength is the incident wavelength, that is lambda equal to 1800 into 10 power minus 10 meter. And the other one is what? Threshold wavelength, that is denoted by lambda naught, that is 4965 into 10 power minus 10 meter. So what is to be determined here is a kinetic energy, Ke maximum we have to find out. Okay. So now we use Einstein's photoelectric equation as usual. From Einstein's photoelectric equation, H C by lambda, this is the incident energy. This is utilized in two ways. So one is the work function H C by lambda naught plus kinetic energy maximum. So this is another form of Einstein's photoelectric equation. We need to find the kinetic energy maximum. Therefore, kinetic energy maximum is equal to H C by lambda minus H C by lambda naught. So this is now equal to H into C common factor into 1 by lambda minus 1 by lambda naught. Just we have to substitute the values. So Planck's constant and velocity of light, we must know the constants. Therefore now kinetic energy maximum is equal to 6.626 into 10 power minus 34 into 3 into 10 to the power of 8 into 1 by lambda. So 1 divided by lambda. Lambda is 1800 into 10 power minus 10. So that now this can be written as what? 10 power 10 divided by 1800 minus 1 by lambda naught. This also can be written as what? 10 power 10 divided by 4965. So that 10 power 10 also can be taken out. So that this is now equal to 6.626 into 10 power minus 34 into 3 into 10 to the power of 18. Okay. Now we have to take this LCM like this. So that this is 4965 minus 1800 divided by 4965 into 1800. So some large numbers will be coming. So we will use the calculator now. So this is now equal to 6.626 into 3. 6.626 multiplied by 3. So this is 19.878 into now 10 power minus 34 into 10 power 18 is 10 power minus 16. Okay, 10 power minus 16 into now 4965. So 4965 minus 1800. So this is equal to 3165. So this is 3165 divided by, this number is very large, 4965 multiplied by 1800. So this is equal to 8937 into 3 zeros are coming. So multiple 10 power 3 I am writing. Okay. So once again this calculation if you do means, so this is now equal to 19.878 multiplied by 3165 So this is now equal to 62913.87 divided by 8937 into, now here 10 power minus 16. When this goes up, this will become what? 10 power minus 19. Okay, so this is to be divided by 8937. So that this is equal to 7.039. 7.039 into 10 to the power of minus 19, and the value is expressed in joule. This is a SI unit. Suppose if you want to express this kinetic energy in electron volt, means you have to divide this by the charge of the electron. Okay, or we can also now express kinetic energy, okay, maximum kinetic energy in electron volt, 7.039 into 10 to the power of minus 19. So I am dividing by electronic charge, 1.6 into 10 to the power of minus 19, so that the unit will be converted from joule to electron volt. So now 10 power minus 19 get cancelled. So this ratio 7.039 divided by 1.6 is equal to 4. So this is equal to 4.399 electron volt. Or we can round it off. We can round it off as 4.4 itself. So 4.4 electron volt. So this is the required answer for the maximum kinetic energy of the ejected photoelectron. So my dear students, here in most cases it is better in the examination if they ask the energy, kinetic energy, incident energy, work function. Always you will have to find both in joule as well as electron volt. Okay. So first we determined this kinetic energy maximum from Einstein's photoelectric equation, and we expressed it first in joule, and next we converted into electron volt, and the answer is found to be what? The kinetic energy maximum is 4.4 electron volt. I hope you must have understood that. Fine.